guys, for today, remind me that I made copies of your worksheets, so you don't have to use notebook paper for today.
Thank you, Ms. Bond. Thank you.
Play basketball?
You shouldn't take candy.
Is it laced?
No,
Are you sure?
Yeah. I got one.
He said he doesn't think it is.
Let's not throw it down first.
Chris,
Did you just go to Jolly Rancher at me?
you were in the last math class.
Chris,
But
would you
like,
Chris, come pick it up.
What?
Come pick it up.
Oh, my bad. Yeah. Miss Bond, remember the sticker incident
16.
in last?
You know, good.
Yeah, you-
Miss Bond, wasn't last first class so much fun? Let's be real, Miss Bond, you had
No,
some fun, right?
it
We know
was-
you had
You just
fun.
trying to stab me?
It was horrible.
It was not
Hey, remember what you said last math class we had together? You said you were gonna stab me, Chris.
Horrible.
It was a fun class.
You don't remember that,
Horrible.
Tyler?
Maybe.
Oh, yeah, hi, Chris.
You don't enjoy rather walking up and shoving every 5 minutes?
100 times a day.
Yeah.
No.
Okay.
I actually need to shove it. Hey, for Ryan.
Owen Baker taught me the best way to sleep in this class.
Okay, so what we're gonna do, guys, is we are going to learn something new today. The ending part of this is just a continuation for yesterday's lesson. And then we're gonna get into similar figures today and similar triangles. And so you'll be able to see what that is like, and then we'll do the rest of the chapter will be on similar figures, okay? So yesterday we talked about proportions and we solved proportions. Today what we're gonna do is we're gonna be writing proportions and then using those to solve, or using proportions to solve like a short word type problem, okay? I do agree that there's other ways to solve these questions, especially this first one. I think a lot of you would not use a proportion for, but with how I'm gonna show you, and because of the fact that the chapter deals a lot with proportions, we're gonna use that. So this is talking about number of sweatshirts and how much it costs, okay? So what we're gonna do is make a proportion, and this first one says we have 3 sweatshirts and it costs $28.50. And it says how much will 14 sweatshirts cost? So this is what we don't know, okay? And then yesterday we talked about how do we solve something like this. What we do, remember, is we cross multiply. So we'd want to multiply this. So we'd go 2850 times 14. And then we divide by the one that's opposite your x. You don't have to show work for this. You can just plug it into the calculator. So you'd go 2850 times 14 divided by 3. And that is $133. Okay, normally it wouldn't come out to an exact dollar amount. It might have cents, so don't be surprised about that. For this one, you wouldn't have to do the 0.00, okay? All right, this one says the ratio of male students to female students in the senior musical at Rocori High School is 3 to 4. So we have 3 male students for every 4 female students. And it says if the number of male students in the club is 18, since I put the males on the top here, I'd put the 18 on top, and then that would be X. And then again, we would just do cross multiply. So we would go 4 times 18 divided by 3. And when you do that, you should get 24 and that is how many females. Okay. Down here it says, on a map, 2 centimeters represents 50 kilometers. So 2 centimeters is 50 kilometers. And actually, normally I put my units over here. So that's really what I should have done. Okay, so we're gonna go 2 over 50 equals, and then it says, what is the actual distance? Oh, sorry. If 2 cities are 4.5 centimeters apart, the 4.5 goes on the top. What is the actual distance between them in kilometers? So that is our x, okay? Now what we would do is cross multiply again. So we would multiply these first. So I'd go 50 times 4.5 divided by 2. So when I go to do that, 50 times 4.5 divided by 2 is 112.5, and that is in kilometers. Notice kilometers is on the bottom, and that's where our x was. Okay, do you guys think those are okay? Not too bad? All right. Now we have one more type of question that we're going to do, and yesterday we did one similar to this. Yesterday, if you guys remember, we were given an extended ratio like this, and we were given a perimeter. And what we did is we put x with each of them, and then we added up the perimeter and set it equal to whatever perimeter they gave us. This is different because today they're giving us angles. So instead of writing them on the outside, we have angles this time, so we're writing them on the inside. Do you guys remember what we put with each of these? The x. So we're gonna put 4x, 5x, and 6x. Now, what do we know about angles?
Triangles equal to 180.
Equal 180. So what we're gonna do is add those together, and we're gonna set it equal to 180 because the 3 angles in a triangle add up to 180. Now, 4 plus 6 is 10 plus 5 is 15x equals 180. And then I'm gonna divide by 15, and I get x is 12. Okay, now here's the deal. 12 is just what we're going to multiply each of these by. They want the measures of each of the angles, okay? So what I'm gonna do is put 12 in here, here, and here. You don't have to, Ryan, shut your MacBook. You don't have to show the work, what I'm doing right now, just so you know. So 4 times 12 is 48. 5 times 12 is 60. 6 times 12 is 72. These are the 3 angles. But like I said, if you didn't show me this, that's okay. But I do want to see this. I don't know how much I talked about this yesterday, but I am picky about showing work. So like in a problem like this, I want to see the algebra that you do, okay? So make sure you show me that. All right, if we look at this one, it's the same thing. We have a triangle, and these again are angles in this ratio. And we put an x with each of them. So one is 5x, one is 7x, and one is 8x. Now when we add those together, if we go 5x plus 7x plus 8x, that equals 180, okay? Now, 5 plus 7 is 12, plus 8 is 20, so this is 20x equals 180, and then we divide by 20, and x is 9. And then what we're gonna do is put 9 into each of these. So if you went 5 times 9, that is 45. If you went 7 times 9, that is 63. And if you go 8 times 9, that is 72. Okay? And those are the 3 answers for that one. Okay? Now we're going to go into section 7.2, and this is what the rest of the chapter is on. It's on something called similar polygons. So, if you guys think back to chapter 4 in whether you had me or whether you had Mr. Check, we talked about congruent triangles. And do you guys remember like learning about side, 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 angle, side, angle, side, angle, 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 side? Okay. That was ways to show that 2 triangles are congruent. And when you have congruent triangles, this is what happens. Every single side of one triangle is congruent to a side of a second triangle. So those 2 might be congruent, these 2 are congruent, these 2 are congruent. And then we also talked about corresponding angles were congruent. So our angles are congruent here, these 2 are congruent, so I'm using 2 arcs. These 2 are congruent, so I'm using 3 arcs, okay? That's congruent triangles. If you had a triangle and you went to a copy machine and you made a normal copy, that would make you have a congruent triangle. There's also something called similar polygons. Today we talk about polygons. The rest of the chapter we're just going to deal with triangles. And what similar triangles are is if you took a triangle and you blew it up, it would be similar. Or if you took that triangle and you shrunk it down, it would still be similar. And what happens with similar triangles is this. Let's say we had a triangle that was 2, 3, and 4 for lengths of the sides. And let's say we took it, and I don't know if you guys know this, but when you make a normal copy on a copy machine, that's 100%. If you did 300%, that means you're gonna make it 3 times as big. If we did that, this side would be 2 times 3, which is 6. This side would be 3 times 3, which is 9. And this side would be 4 times 3, which is 12. Okay? Every side would just be a multiple of 3. Then, what would happen is your angles stayed the same. So if this had 1 arc originally, it would be congruent to this, and it would have 1 arc. This angle would stay the same as that angle, and this angle would stay the same as that angle. So what happens when you take a figure and you either blow it up or you shrink it down is 2 things. One is your angles are congruent, just like they were in congruent triangles. But in a congruent triangle, your sides were congruent. In similar figures, what we say is your sides are proportional. And what that means is when you go and find the ratio from your smallest side, which is 2, over your smallest side here, which is 6, and you reduce that, you would get 1/3. When you take your medium sized side here, which is 3, and you put it over your medium-sized side here, which is 9, and you reduce that, you still get 1/3. And then when you take your largest side here, which is 4, over your largest side here, which is 12, you still get 1/3. So instead of your sides being congruent, your sides are in the same ratio. If they're not, that means it's not similar, okay? Another thing that will happen today is they'll ask you to list your corresponding angles, and you're just looking at how many arcs they have to determine that, okay? And then this right here is called a statement of proportionality. And sometimes you will just see it proportionality. Sometimes you'll see it in my notes where it just asks you for the proportion. That's what we're asking about. So what happens in that is you're going to take, like in this, I think I'm gonna wait until I get to an example to explain it. But let's say this is the smallest side of one polygon over the smallest of the other. This is next smallest over next smallest, the next smallest over the next smallest, and then the biggest over the biggest. When you write it out like that, that would be the proportion they're looking for. Then, the last thing that they will ask you for is called a similarity statement. Okay? And when you do that, do you guys remember in the last chapter writing like triangle ABC is congruent to triangle DEF? A statement of similarity, what happens there is you write that the two things are similar, and the similar symbol is this. It's the symbol that's above your equal sign. Okay? So, I just said a lot, but basically what happens is if they ever give you a similarity statement, you can tell what angles are congruent by where they are in this statement. A comes first, so A is going to equal E because that one comes first. B is second and F is second, so they're congruent. C is third, G is third, so they're congruent. D is fourth, H is fourth, so they're congruent. And then this is called the proportion. And watch this, because this is a little bit different. These are sides, okay? So if you took the first two letters here, A, B, that would go over the first two letters there, E, F. Then if you took the two middle letters, B, C, that would go over F, G. If you took the last two letters, C, D, that would go over G, H. And then the last one is if you take the first letter and the last letter, that would go over the first letter and the last letter. Now they wrote it as DA, which is fine. I actually would write that as AD over EH. Not that that's a big deal. Okay? So, we are going to try one of these. So, if you go to this page in your notes, here is what we're gonna do. They give us this similarity statement. We're gonna go down here and fill in what angles are congruent. How you tell that is where they are here. A is first, so what do you think A is congruent to? X, because that's first. Very good. B is second, so what is B congruent to? Y, very good. C is third, So C is congruent to Z. Perfect. Okay? Now we're gonna do the proportion. And with a proportion, you write the sides with 2 letters. Okay? So here's what we're gonna do. We're gonna take the first 2 letters, AB, whoops, AB. What would AB go over? AB is the first 2, wouldn't that go over XY, right? Okay. Then we have BC, what would that go over? YZ, very good. And then the last one you always have to do, you guys, is the first and last. First and last. And this is what I was saying. It doesn't matter if you call it AC or CA, it's the same thing. I generally call it AC, and that would go over XZ. Is that easy enough? Okay. Let's look at this one. Okay. What would angle J be congruent to? P. What would H be congruent to? Q. What would F be congruent to? S. And then lastly, what would M be congruent to? T. Okay. Now let's try that proportion. JH would go over what? Very good. And then wouldn't you do HF? And what would that go over? QS. Very good. Then you would do the last 2, FM over, very good. And then we would do the first and last, and that would be JM over PT. Perfect. Is that okay? All right. Now, one of the things they're going to ask you to do today is find what's called the scale factor. And the scale factor is like back here when I found all these ratios. The scale factor is 1/3. Okay, that's what they mean by that. So we're gonna go over one more page and then we'll be done. So the second type of problem that you guys are gonna have today is they're going to give you 2 figures. Sometimes they're triangles, sometimes they're 4-sided. Doesn't matter really what they are. The first thing that you're gonna do is look at the angles and see, do I know that my angles are all congruent? Now, do you guys see how this angle and that angle each have 1 arc? And this one and this one have 2 arcs? Now, there's a theorem that we learned, and I don't know how much Mr. Check talked about this. It's not a super big theorem at all, but did he talk about the third angles theorem? Okay, this is what it says. If 2 angles of one triangle are congruent to 2 angles of another, the third angles are also. Very good. Okay, so we do have all of our corresponding angles congruent. So we're good. If that was, I have something stuck in my throat. If that was not true, sorry. If that was not true, you guys could stop right there and not finish the problem. Okay. Now we know that, so we're gonna try these ratios, and this is how I show it. I have you guys take one of the triangles, doesn't matter which one, and look for what is your smallest side here, and it's 12. And then you look at the other triangle, and you look at what is the smallest side here, and it's 18. And what we're gonna do is reduce that. Now, this is what the graphing calculator does for you in case you struggle reducing fractions. Let's say you're somebody that 12 over 18, I'm not quite sure what goes into both, I'm not confident I did this right. you can go to your graphing calculator and you can do this. You can go 12 divided by 18, and then you hit this math key right there and hit enter twice, and it will reduce any fraction for you, okay? So that's 2/3, and some of you might be like, oh, I don't need that, I can do that in my head. Great. Medium size side here is 14. Medium size side here is 21. Do you guys know what goes into 14 and 21? 7. How many times does it go into 14? 2. How many into 21? And notice they're the same, so we keep going. Then let's try big over big. Biggest side there is 16. Biggest side here is 24. What's the biggest thing that goes in there? 8. 8 goes in here twice. 8 goes in there 3 times. Do you see how all 3 are the same? And these were all the same. That means our triangles are similar. Now, if both of these are true, you keep going. If either of them were false, did not work, you would just stop there and say not similar. But we're gonna keep going, and they want us to write a similarity statement. It's just like when we had chapter 4 and we wrote something like this, okay? Except this time the symbol is like that instead of congruent, okay? So let's go. Here's what I would do on this. I would start at one of my triangles, again, doesn't matter which one, and I would use my angles. And I would look at the angle that has 1 arc, then 2, then 3, and I would name it in that order. So I'd go from A, because it has 1, to B, because it has 2, to C, because it has 3, and I'd write this as triangle A, B, C, and then I would do that squiggly, which means similar. Now, what order do you think I'd have to do this one in? U, V, is that a T? See how I went 1 to 2 arcs to 3 arcs? I'd have to go 1 to 2 to 3, so I'd go U, V, T. And that is called a similarity statement. Now, the reason I did your worksheets for you today and printed them is I set this up for you, so all you have to do is answer these. Now, the last question it asks us here says, what is our scale factor? Our scale factor is 2 over 3. That's all you put here. Now, if somebody else did this triangle over that triangle like instead, they would have gotten 3 over 2, and that would have been fine too. So the reciprocal of that always works also. Okay, let's try this one. All right, so we have an angle here equal to an angle here. We have another angle here equal to an angle here. Then, can I assume those two are going to be equal? Yes. Okay. So, my angles are good, and I can say yes right here. Now we're going to try for our different things. Small over small. I always start with the triangle on the left, so I'm going to go 6 over 4. Do you guys know what 6 over 4 reduces to? Divide by 2, 3 over 2, very good. Now medium is 9. And medium of this one is 6. 3 over 2, very good. Now, this is where your graphing calculator comes in nice. This has a decimal, which makes it yuckier. And that is over 6, okay? Oh, I'm sorry, 7. Sorry. Okay, when you go to do this and you don't have a graphing calculator, you can do it, but how you would do it if you had this is you would have to multiply the top number and the bottom number by 10. And what would happen is that would clear out. That would make this 105 and this 70, and then you could use your calculator to do it. But a nice function on the graphing calculator is you can do decimals on there. So we can go to this calculator and we can go 10.5 divided by 7, and then do you remember what we hit? Math, oops, and I got that wrong. I can delete that and go back and go math, enter, enter, and it reduced it for me, and it's 3/2. Now, are these similar? Yes, right? And we have to write a similarity statement. Now, when you write one, there's a number of ways you can write it. I'm gonna go to this, and I'm gonna go from the 1 arc to 2 arcs to 3, and I'm gonna call this triangle CAB. Is similar, remember, is just that squiggly. What order would I do this in? F, D, E, very good. And then what is my scale factor? 3/2 or 2/3. Both are acceptable. Okay. Now, if I look at this one, do you guys know that a 4-sided figure has 360 degrees? Did you guys know that? So if these are 90 plus 90 plus 90, the other one would be 360 minus 90 plus 90 plus 90 is 270. So that is 90. So if 3 angles are right, we can assume the 4th angles are right. Okay? Now, this is a rectangle, and we have, that's 10, so that would tell us this is 10, that's 4, that's 4. This is 18, that's 18, that's 9, that's 9. So are our corresponding angles equal? Yes, because they're all 90. Now in this one, we only need to try 2 of our ratios because of the fact that there's only 2 sides that are different. So the small side here is 4. The small side here is 9. And now here's another thing that your calculator would do. Let's say you're like, I don't think I can reduce 4/9. You could go to your calculator, set it up, 4 divided by 9, go math, enter, enter, and notice it stays the same. That means it's reduced already, okay? Large over large would be 10/18. What do you guys think that reduces to? 5, they'd both be divisible by 2. Are these the same? So what you can do there when they're not the same is just say not similar and you're done. You don't have to fill out anything else. You're just done with that problem. No would be fine too. Yep, no would be fine. Now we have one more and then I'll finally shut up. Okay. Do you guys get in this one? Well, actually, are these even gonna work? Because there's not a 42 over here, there's not a 48 over here, so they're just not, right? But I just wanna show you one thing. Let's say that we were doing the smallest side over here, over the smallest side here. If there's decimals like that, would you know to just go to your graphing calculator and do it? Because it just makes it easier. But this one does not work, so you would just write no. Everybody get that? Okay, so I have a worksheet for you. I did put a key up front so you can check your